Hello everyone, and welcome to this Telit and ASOX webinar, Creating 5G-Powered Seamless Private-to-Public Networks. Thanks for joining us today. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating our discussion today. Before we start, we would like to understand how you would describe your interest in private 5G. So if our audience could please take just 1 second to fill out the poll question, which you should see on your screen now. Now let's get to know our speakers. To explain this topic today, I'm pleased to be joined by two speakers. First, we have Marco Contento, the VP of 5G Technologies at Telit. Second, we have Gilad Garon, CEO at ASOX. Just before I hand it over to Marco to start the presentation, I do have a few quick reminders for our audience. I would like to encourage you all to interact by posting questions, and we will have time to answer some of those at the end of the presentation today. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for some additional information on today's topic. And finally, we will send out a replay link to all attendees at the conclusion of the webinar today. And with that, Marco, I will hand it over to you.
Thank you, Amanda. Thank you, and good morning to the audience. Okay, so the first part that I will present from my side will be essentially an overview on what is a private network and the advantages and the possible, let's say, configuration or deployment options that are essentially available to the enterprises. A private network is essentially a network infrastructure that is used exclusively by device that is authorized by the end user organization. Typically, this infrastructure is deployed in one or more specific locations which are owned or occupied by the end user organization. Devices, in this case, which are registered on public mobile network, are not allowed to log into the private network, except in some specific cases where they are authorized or there is a kind of roaming agreement. Mobile network operates in specific frequency bands, and this ensures, of course, reliability compared to the, for instance, unlicensed frequency bands that are typically used in Wi-Fi networks. In some countries, the spectrum is also specifically allocated for industrial use. An example is Germany, including private networks, but more in general, it's expected that the mobile network operator will offer private network solutions based on their own licensed spectrum in several methods that we will see in the coming slide. The spectrum license to mobile network operator is generally greater, and these therefore support higher bandwidth services for industrial enterprises. In addition to that, there is also the option to have an agreement with the network operator that is providing the private network in case there is the need also to have a kind of roaming, for instance, for application like logistics, where there is also the need to roam or to move externally to the private network. Now let's have a view on what are the IoT connection in the private network space. Taking out the legacy 2G, 3G technology that at this point is becoming not relevant for our study, because if we look at the number, essentially the numbers are dominated in general by 4G in the different flavor. And on this regard, I would mention broadband applications, and on the other side, everything that is related to LPWA, so LTM mainly. And let's say that the two areas, so broadband and LPWA, are essentially the two dominant segments. The first one, I mean, broadband was the first to ramping up. The research in this case shows that there were about 200,000 cellular IoT connections worldwide in private networking at the end of 2017, and this then grew to above 400K by the end of 2018. Of course, with the opening of a license or share spectrum in some markets like CBRS in US or multifier that will become relevant in Japan, but also in Europe, or other initiatives like in Germany, a rapid growth of about 70% per year is expected. So the research showed that by 2025, nearly 20 million broadband connections are expected to be installed. In parallel, there is also a strong growth for cellular LPWA connection. For initial, let's say, about 50K in 2018, including essentially LTE devices, to over 24 million connections by 2025, with an annual growth of over 136% in the period. Now, looking at the network, private networks by regions, this slide depicts the situation at the end of 2020, where essentially China was dominating the number of networks, essentially because the local presence of infra vendor play like Huawei and the support of the state that has helped the market in China to develop. Most of the China private networks are being deployed for transport and smart city project. Then there is North America. The amount of private networks in activity in North America is high. There are above 20 private LTE or 5G networks in US and 9 in Canada. The market in USA has essentially benefited from commercial available CBRS spectrum, and half of the 24 US-based private network are essentially based on CBRS spectrum. Western Europe, surely the local presence of the network provider like Ericsson, Nokia, and also more important government initiative play an important role in the private network market, in particular in Germany, we can mention. And also the role of some network operators that are moving ahead, offering the private network support to the enterprises. What are the benefits of a private cellular network? Well, first of all, in terms of deployment cost, a few cellular base stations can easily replace several Wi-Fi access points, not only from cost of the hardware, but also in terms of installation cost. Reliability, because the fact that it is deployed in a licensed spectrum, so the access is somehow controlled. Of course, the reliability of the communication is much higher, and also the latency is lower, and in particular when we look forward to release 16 capabilities. Coverage is also a good point because the transmitted power by the base station is higher compared to Wi-Fi, so there is the possibility to have better coverage, in particular in not only in outdoor environment but also indoor environment. And also not to forget the mobility that is completely supported, being based on a cellular system. Versatility, of course, a private cellular network can offer not only data connection but also voice connection in case there is a need, and these allow, of course, to replace legacy systems. Security, this is also an important aspect.
It sounds as though we have lost Marco's audio here, so give us just 1 second to troubleshoot, sorry. We'll give Marco just 1 second here to get reconnected.
Okay, I hope you can hear me now. I've been disconnected by the phone system.
No problem.
Okay, I apologize, really apologize. Back on the session. Yeah, I was essentially depicting the advantages of the benefit of the private cellular networks. I was mentioning security that somehow can be controlled by the enterprise that has deployed the private network, so all the sensitive data can stay essentially on the premises. Now, looking at the different radio technology that the statistics show in the case of an enterprise users, of course, Wi-Fi is the dominating technology, followed by cellular. Of course, due to cost and control that essentially was available till so far. Bluetooth is still also present, in particular to connect devices like barcode reader or simply to configure a device or tool. Also, LoRa and Sigfox are used, and those technologies compete with cellular. Of course, the companies are now mixing different technology, can use either Wi-Fi or LTE depending on the specific needs. LTE is becoming also very popular in the area of hospital for security reasons, but also to lower the cost of the installation in terms of hardware, but also simply the cables and repeaters that are needed in order to propagate the Wi-Fi signal across all the hospitals. Now, looking at the possible area of typical sites where private networks are deployed, there are several use cases that can be mentioned here. So mining is one segment where usually there is no coverage of a mobile network operator at all, or shopping malls, so large retail areas, oil and gas, military bases, power generation, and in this case also Release 16 will become relevant for the low latency capabilities, in particular to synchronize the power generations with other generators. All the logistics will benefit, so airport, ports, and so on, and many others, so including also warehouses. In this case, we might mention AGV, so automatic guided vehicle, that will leverage in future also the 5G. Regarding the typical deployment options, here in this slide, we of course have a simplified view. So we move from the first dedicated private network that is depicted on the left side, where essentially there is a specific installation for the enterprise. So everything is there, and in this case, the enterprise has complete control and of the system. But there might be issue with the interworking with the public network unless there is a specific roaming agreement. And then there is something in the middle, we call it the hybrid private network. In this case, the base station essentially is deployed in the enterprise, but the core network is managed outside. The last is the virtual power private network. Essentially, all the equipments, the G0B and the core network are essentially owned by the mobile network operator, and in this case, they lease a slice of the network in order to provide this kind of services. Of course, for each of them, there are pros and cons and different characteristics that are delivered. Now, if we look in particular at the private deployment, where all the logical parts are completely deployed inside the enterprise, of course, having all the elements inside the enterprise brings all the benefits, and therefore the enterprise can leverage low latency, can leverage also or let's say differentiate the quality of service depending on the internal use cases that they want to support internally. In this regard, it depends also by the availability of the spectrum, whether it is a shared spectrum or it is a dedicated spectrum, or it's a public spectrum provided by the mobile network operator in this case. Before we have shown the three simple possible deployment scenarios, but in reality there are many others that can be mentioned. In this slide, the first two are essentially related to deployment that is done at the enterprise level, and between the first two, essentially the difference is in the spectrum. So in the first one, there is a local 5G frequency allocated, typically I mentioned before Germany, and this is the let's say bit use case. Or the other option could be that the frequency bands or spectrum that is used is a public or own spectrum. All the others, where we essentially group under the shared 5G network, the cut of the other, the different configurations can be slightly different depending on where the routing of the packets essentially is done. The most common probably are the first three, where the RAN sharing is done in a different way with different elements involved. Now, looking at what are the problems that we can solve with the tele solutions, in the product that we have developed, the 5G product we have developed that are M.2 data card, we do support the TDD bands that are essentially using the private deployments, so like CBRS band 48 for US, Germany that is using band N78, so actually a part of that spectrum in the range of 3.7, 3.8 gigahertz. And we do support also standalone mode on those bands, and we support also network slicing, and therefore we can leverage the different quality of services required by the industry. Going to the second, sorry, go back too fast. Looking at different sectors where there is traction for private deployments, we see manufacturing the most interesting segment where there is the need or use of private deployments. Just right followed by transportation, and we saw something before already, then mining and other sectors. Utilities probably will leverage, will require low latency communication, will probably be relevant for the release 16 capabilities. Of course, these segments are already served by LTE, but 5G is becoming more and more interesting for the industry as we see more traction with 5G. Now, if we look at the different traction that the technology has today, the majority, as we said, of private network deployment are in industrial sector. However, there are specific enterprises that are using networks, private networks, to connect, for instance, AGV and industrial equipment. Many of the manufacturing firms using private networks are usually large and multinational companies, such as BMW, Bosch, Mercedes. Some of them have already planned to install more private networks in other plants, so they've started with a few plants, and they are going to expand also in other plants or even outside the main region where they started. And of course, you can see also split here between 4G and 5G. You see that in manufacturing, 5G is becoming much more relevant, most likely for the features that 5G is promising to bring, in particular with the release 16 specification that is essentially available and will provide or will offer product during 2022. Now, looking at the spectrum initiatives worldwide, in this slide we can see all the spectrum initiatives, not only in Europe but also outside. So not only Germany and USA that we have mentioned so far, but also other countries like UK that is relevant, or Netherlands or Belgium. But you can notice that in majority of these cases, the spectrum that is under consideration is the C-band spectrum, so usually around 3.5, 3.7 gigahertz. And there are also initiatives for using millimeter wave spectrum. Japan is a case where the government has assigned, for instance, to Fujitsu a private license to use LTEs and anchor band, and also millimeter wave spectrum, in particular band 257, for a private deployment, in particular for their plants, and also for a campus they have installed. Okay, I've completed my presentation, so I hand over to Gilad for his part.
Thank you, Marco. Hi, everybody. My goal in my short presentation is give you guys the possibility to get a little bit more of a flavor and a color to private networks, specifically in the industrial use case, and perhaps zooming out a little bit out of the 5G protocol advantages, and also to the interesting phenomena or trend, which is the merger of 5G and edge clouds. So as Marco has described already, there is quite a consensus in the market that the industrial use case would be, at least for the next few years, be responsible for the lion's share of 5G private network deployments. And this is not just an aspiration or a bold prediction. It's actually based on several key factors that make the industrial use case, or the way we described it, the non-carpeted enterprise, so mission-critical enterprises, different than many other networks in the more traditional office space or hospitality or other places where private networks or in-building coverage was available in the past. So when people talk about 5G, there is a big bias towards bandwidth and speed. And of course, that is driven by the private consumer market, where operators are competing with each other for faster internet. But when it really comes to the industrial use case, while important, these are not the key drivers for factories to make decisions to turn to 5G. First and foremost, in order to address that market, it's about high reliability. And one of the interesting terminologies that have emerged in the 5G ACIA forum is not to focus on super low latency or URLLC per se, with its so-called declared 1 millisecond latencies. But customers actually came to vendors such as ourselves and said, we would prefer to have the network at 7 or even 10 milliseconds, but we want to ensure the predictability and the low distribution of data, and that feature is called TSN. So in the industrial use case, high reliability and TSN are probably more important than fast internet in an ultra low latency aspect to the extreme of 1 millisecond. Then, of course, other implementation factors, such as virtualization, which in the macro network may be deemed as a way to improve efficiencies in the way the network is operated. In the industrial use case specifically, or in enterprise in generally, how do you deploy, manage, and consume the 5G service is no less important than some of the other features that 5G can present. So when you look at the trend in the industrial segment, it's not just about deploying a reliable 5G network anymore. It's really about how do you deploy it. So other than the physics of open radios, which, as Marco has mentioned, are now at the price point of Wi-Fi hotspots, if not below, because of their ability to distribute larger spaces than Wi-Fi hotspots. It's really about the software. And the way the software for the 5G RAN and core is deployed, we are seeing a great demand for a deployment on edge cloud systems such as Azure, Stack Edge, or Amazon Outpost. We are seeing, of course, other implementation in, let's call it, more classical IT under companies such as VMware or Red Hat. So the way that you build and implement the 5G private network is a key factor in the success of these integrations. Another key element that I think is an interesting data point to the audience is how does a typical deployment really looks like in a production floor. So to some of you that are familiar with RFPs at the LTE world, let's say in hospitality, it was always about supporting thousands or sometimes tens of thousands of devices in a stadium, large venues, etc. But really, the interesting factor is that more than 80% of all industrial locations worldwide are smaller than 50,000 square feet. And that is a very important fact, because what it basically means is that with 3, 4, or maximum 5 open low power radios, you can actually cover that whole venue, making the cost of hardware or the traditional RF part of things pretty insignificant in the total value of the managed service. The other element is to realize about devices, specifically in 5G, given where the market is at, but also given the significant differences or advantages that 5G can provide. We're not talking right now about big device installations. So the average installations we are seeing now are in the tens of devices. Marco has mentioned AGVs. That's a great example where mobility and uplink speeds are required. That's a classical use case for 5GSA, but also connecting of video-intensive cameras and actual machines, as we will see very shortly in the use case that I will present this morning. And another key factor is to understand roughly the data consumption. In the classical private LTE oil and gas installations of a few years ago, really capacities of 1 gigabit in aggregate would have been a fantastic number. In 5G, we're seeing the need for 2, 3, and sometimes even 5 gigabits of capacity available on-prem. And of course, that makes another motivation why you want to have most of the, if not all of the traffic localized, making on-prem 5G private networks more logical. So once we realize that in the foreseeable future we are talking about relatively small number of devices in a controlled environment in the industrial use case, the focus then turns into the value of the information that this private network is controlling. So what would be how do you look at the value of the 5G data-driven environment? One thing is, of course, analytics. Big data analytics has always been important in today's world where every bit of information can be then transformed into efficiencies and profit. That value of information is even extended over the past. Another key element when it comes to data analytics is that the fact that in edge clouds, there is much more firepower, whether it's hardware such as GPUs or simply backhauling some of that information or the metadata to the cloud. There is a lot of firepower available for the 5G private network to run real-time analytics. Streaming of virtual reality and augmented reality is, of course, very important in applications such as digital twin. If people are curious, then the latencies required for augmented reality that we are seeing are in the area of 7 to 12 milliseconds. So there is absolutely no need to wait for release 16 in the later features in order to benefit from these kinds of numbers. And these would be available through this cooperation that we have here with Telit. Specifically, other than connectivity, there's a few services that we as a company are intending to develop and would probably be available also with competitive solutions. One of them would be pinpoint location accuracy of the devices. In-building location has been an unsolved problem for the last decades. With 5G, the 3GPP, it's really the first time that the 3GPP and other organizations are tackling in-building location at the level of detail which is required for success. And as we mentioned, because of the specific topology of ORAN, then it's much more native for use of algorithms and integrations. So where are we in the market? Well, 2020 was really the year of experimentations and early trials, not just for us, but for the industry. But in some advanced markets, such as Taiwan, and Marcos mentioned Japan and Germany as industrial countries that have a solid shared spectrum policy, Taiwan is very similar in its attribute to Japan and was very fast to adopt these technologies. And of course, it is a highly industrial venue. Therefore, Taiwan was a hotbed and a hotspot for ASOCs and its partners to deploy 5G private networks. The Inventec use case is probably one of the best examples in the industry about the benefits of 5G private networks. This specific case was done in partnership with Microsoft, or a division within Microsoft called Affirm Networks, and I encourage you guys to probe and learn from this use case. I think the highlight of this use case was that we connected using 5G optical inspection machines. Now, these optical inspections machines were still fettered using cable to their existing created application to run their function. But what we were unable to achieve using 5G was to create a cheap way to move loads of images and data created by the machine directly into an AI application in parallel to the current machine functionality. And that achieved phenomenal success numbers by increasing first pass yield of that specific machine from 70% to over 85%. So when we look at 5G as a technology, we shouldn't just look at it as yet another air interface that we want to build sensor on top on, but also as an additional layer to the existing feathered or cable-based production floor. Just a little bit about what makes ASIC-driven 5G private networks unique. We strongly rely on the Open RAN initiatives, and what it does in practice is it enables any third-party radio vendors to be connected to the platform. The second element is that we do not require any type of appliances of hardware acceleration, so any server of any type can be used as a platform to run this software. Clearly, in a managed cloud environment such as Amazon Outpost or Azure ASCs, that decision is made already by the cloud provider. And these two key elements create this cloud nativeness. And cloud nativeness is not just a slogan. What it really enables integrators and enterprises is to also embed easily additional low latency or on-prem applications in conjunction with their 5G application. Marco has described a lot of the technology alternatives, so I don't think it makes sense to go over them too much. I think that one of the key questions that we get in these types of events is, how do you relate over Wi-Fi? And I think that the fair answer, or the best way to look at it, is that 5G is an envelope of possibilities. You can drive it to extended speeds. You can drive it to super low latency. You can drive it to massive IoT connections of millions of devices. So when you really try to compare Wi-Fi to 5G, you should also ask yourself, what type of Wi-Fi to what type of 5G? And assuming you're going after Wi-Fi 6, then I dare say that Wi-Fi 6 can present good speed numbers, but the way I kind of like to look at it is that cellular is a much more predictable manner of managing devices. So that is more important in the use case than more times than not. Enterprises and integrators will choose cellular. Given the fact that on the 5G private networks, as we are moving to full software, the comparisons will not be really between Wi-Fi and 5G as a technology, but more between 5G managed services and Wi-Fi managed services. And when that comparison comes to mind, the gaps in terms of and business models are going to look more and more the same, with the intrinsic advantages of 5G coming to play. So I hope I managed to give you guys a little bit more of a color about the specifics of the industrial 5G private networks and the new trends of deploying these networks in software on IT equipment or private clouds. And Marco, I hand off the discussion to you to perhaps tell a little bit more about the actual devices which are coming into play in these deployments.
Marco, I'm not sure if you're running into audio issues again. Are you still here with us? Perhaps, Gilad, on the next slide, you can go through the kit that Telit and ASOCs have put together.
Sure. So, as we described, in 5G private networks, it's really going to be about the end-to-end performance. I mean, this is always true in cellular networks, but in 5G on-prem networks, the intimate relationships between device, RAN software, and core are even more important. So in order to, on the other side, this is a new topic. 5G is a new topic. Software RAN, open RAN, on-prem core, and new devices require some learning curve and training from end customers and integrators. So in order to speed and enable a more frictionless and intuitive approach to 5G, we have come up with the concept of this evaluation kit, which is an out-of-the-box full 5G experience, starting, of course, from the tele-devices, configured SIM cards that are provided in the system, open radio units with the relevant frequencies, whether it's Germany, Taiwan, or Japan, or the United States over CBRS, and then a small IT cloud consistent of off-the-shelf servers and switches with all the software and management and control tools. So it's really a micro network in a box, and we see a lot of value in using it. And of course, now with the support of Telit, we're also coming with out-of-the-box portfolio of devices, including a Telit 5G hotspot, but of course modules that can be integrated into the relevant devices. So we encourage you to have a look at these and approach both ASOCs or Telit based on your interests.
Thanks, Gilad. And just for our audience reference here, there are some direct links in the resources section in the upper right-hand corner of your screen, where you can check out some more information on this evaluation kit and a few other things that were discussed today. Before we get to the questions here, I am going to drop just one last poll for the audience. If you'd like one of our experts to contact you directly, please feel free to respond in the poll here and we will get someone to reach out to you. We do have time for a few questions now, and we have gotten some audience questions. There's still time to ask a question, so please feel free to submit using the box to the right of the presentation, and we will do our best to cover it in the time that we've got left. So let's just jump right in. The first question that I see here, and Marco, let me know if you can hear me all right. First question I see. Perfect. Will there be a dominant deployment architecture for private 5G deployments?
Well, I don't believe there will be a dominant deployment architecture. It will depend very much by the country and the regulation. Probably in Germany there will be the pure private 5G network will be maybe will represent the majority of the deployments, but the majority, the other countries most likely will rely on the public network for deployment. So it will be kind of shared network with different possible deployment options.
Great, thank you. Next question I see, what are the main cases in the production assembly line that are most benefiting from 5G?
Well, as we described, the combination of low latency and bandwidth, specifically uplink bandwidth, drive some of these applications. But as I described, one of the key parameters to look at these applications is what is the value of the information derived out of the connectivity. So high precision or high resolution images, whether they're still and of course video, are really driving the usage of 5G private networks. And in the industrial case, these video images are typically associated with applications such as asset tracking, mobility tracking for AGVs, and as I described in our latest use case, optical inspection and other image-driven applications at the factory floor.
Great, thanks, Gilad. And another question that kind of follows on that a little bit. What are the advantages that 5G brings in the context of manufacturing that 4G could not?
Well, this is Marco speaking. Essentially, the benefits are the new capability that 5G has, let's say, will bring in particular with the upcoming 3GPP release 16. We mentioned before low latency. We mentioned reliable communication. Essentially, all these are aspects that could not be addressed with the previous technologies. And also, regulation aspect will also play a role in the future, in particular enabling the industry to use this technology to essentially fulfill the needs of Industry 4.0. These are essentially the key elements that we see.
Great, thank you. Mark, I believe this question is for you as well. We're very interested in 5G location, but we all need release 16. When will Telit modules like the 980 support release 16, and what level of support for release 16 location will be provided?
Okay, good question. The current products that we have are release 15 compliance, and we don't expect that it will be capable to be upgraded to release 16. Of course, it depends on Qualcomm on this aspect. Probably, as you know, the product is based on SDF55 chipset. This is, the reality, and we are now working on the next generations that will be based on the SDX62 and 65. And we have publicly announced this move that will generate new products that will be release 16 compliance, certified next year, essentially, even if the engineering sample will be available before. Regarding the ULC capabilities, those will be available not at the initial release, but will come later with the maintenance release that will be provided by the chipset supplier.
Great, thanks, Marco. Next question I've got from the audience here. The first benefit of private networks that you mentioned is low cost. Private cellular networks have a lower cost than Wi-Fi. Could you explain how?
I will take this question. Essentially, and then of course, Gilad, you can always comment right after. Essentially, the cost saving that we expect to see is the reduced number of hardware that are required to be deployed in the case of cellular, because with a few base stations, we essentially cover a wider area compared to Wi-Fi. And not to forget the fact that there are also installation costs, because deploying several Wi-Fi access points into a building, of course, require a relevant effort, and also repeaters and therefore. And also in terms of coverage, because the power emitted by the base station or a cellular base station actually is higher compared to Wi-Fi. Of course, there is advantage in this sense. So there is the possibility to have coverage inside the building without, let's say, a huge effort in terms of deploying the access point.
Great,
yes,
thank you.
I think Marco answered that very well. As I described, when people think about cellular deployment, they still think about the existing paradigms of pricey closed-door solutions. And once the implementation from the network side is moving to software, it's really about just like any other cloud service. So it's really a pricing, and when technology moves from sheer technology into a pricing model, then at the end of the day, market dynamics will determine the final prices of cellular and Wi-Fi. But there's absolutely nothing in the cellular technology, contrary to, let's say, common belief, which makes it more expensive than Wi-Fi at all. And as Marco has said, actually within cellular, there's a lot of intrinsic benefits that can make it much cheaper at scale.
Great, thank you both. Next question I've got, what are the benefits of a software-based 5G private network over a hardware-based system?
Well, as I described, at the risk of being a little bit repetitive, first of all, you have the operational benefits. That means every enterprise integrator can make his own decisions about the underlying hardware, making it more applicable, on a regional basis or from a sourcing perspective. Another element is that the hardware equipment is not just used for the cellular technology, but can also be used for other edge applications. And actually, in most of our implementation, the same server, which is running RAN and core application, also runs other NEC applications. So really, the hardware box goes away in the software model. Another element is, of course, competition. The more software vendors are there, that's another factor of driving the cost down. And from another key, operational and maintenance, it's much easier to maintain, upgrade, and support software than it is hardware. And that's probably the most dramatic difference between servicing rigid hardware-based solutions over software.
Great, thank you so much. I know we are headed to the top of the hour here, so I believe that's about all the time we've got for today. Audience, thank you so much for joining us today. Please be sure to check your inboxes in the coming days for the replay link of today's presentation. Marco, Gilad, thank you so much for your time today, and thank you to all who joined us. Have a wonderful day.